Thanks for your patience, everybody. I'm Seth from EFF, and it's nice to be back here at LinuxFest Northwest. I saw some of you in this room yesterday for the ACLU panel, and thanks to everyone for coming here after lunch and for hanging out while we dealt with these problems. So I've been working on the Let's Encrypt project for quite a while. I actually spoke about Let's Encrypt last year. And the nice thing is that last year when I spoke about it, it was something we were planning to do. And this year I'm happy to be back to describe how it's working really well and has been very successful. I have some of the same slides, and I also have new slides, and I have a demo where I can actually get an HTTPS certificate here in front of you that your browsers will accept, something that I wouldn't have been able to do last year. So that should be fun. Some of my colleagues have suggested there are a lot of acronyms here, and so it might be good to just go over them in the hope that people will become familiar with them if you're not familiar with the acronyms. There are, of course, many more acronyms where these came from, but as a start, there's a security technology for the internet called Historically Secure Sockets Layer, or SSL. SSL was renamed to TLS. It's hard to rename things. The renaming doesn't always stick. The sponsorship of Sears on the Sears Tower expired, and someone else bought the sponsorship, and apparently we're supposed to call it the Willis Tower, the really tall building in Chicago. But a lot of people keep calling it the Sears Tower. And so SSL, or TLS, is having the same problem. We're supposed to call it TLS. That's the correct modern name. It's technically incorrect to continue to call it SSL because that name isn't even on the new standards documents. But that name has definitely had a lot of staying power. So SSL and TLS, for many purposes, are the same technology. This is a technology that adds security on top of TCP for the internet. When you use that for the web, you get HTTPS. So HTTPS is the application of TCP to the web. There's also technology called X509, which is the format that's used for the certificates, like we're issuing. The certificate infrastructure collectively is known as a public key infrastructure, or PKI, and the entities that issue these certificates are called CAs, for certificate authority, and we are one of those. I may still use other acronyms that I haven't mentioned, but you can feel free to ask me about those, and I hope that that helps. So as I said last year I was here, I was also invited over to WWU to speak about this, as well as LinuxFest Northwest. And then it was this thing that we were doing that was hopefully going to work. Well, we got our signature from IdenTrust, we went into limited beta, we went into public beta, and now we're out of beta, and now I'm back and this thing works. And in fact, I ran into an amusing problem about this, because when I was proposing the talk, we had issued 500,000 certificates. So I said, okay, my LinuxFest Northwest talk can be, let's encrypt our first 500,000 certificates. And then in March, we reached 1 million. And it was already, I think, too late for me to change the title of the talk. And then last week on Thursday, we reached 2 million. So in fact, this is really a talk about our first 2 million certificates, despite what it says on the program, because we've really been growing very quickly. This is a graph of the certificates that we've issued. It may be a bit hard to see from the back, but you can see it on Let's Encrypt website on the stats page. This orange line here is the total number of certificates that we've ever issued, and you can see it flowing past various milestones, including on Thursday the 2 million mark. So people are using this quite a bit. And a nice thing to point out is that a certificate can cover more than one name and can cover more than one site. So there's a technology called subject alternative names in the X509 specification, in the X509 version 3 extensions, that lets a certificate cover many, many names. And so, in fact, most of these certificates cover more than one name. And so, I wasn't able to find out exactly how many names we're covering, but I think that we're covering on the order of 10 million sites with these 2 million certificates. So it's really quite popular.
This isn't taking into account the 3-month expiry, like...
No, so there's some of these are expired.
Right.
So we don't have 2 million certs that are valid and that are being used. We have more than 1.5 million that are valid and are being used. But 2 million that we've ever issued. And hopefully soon we'll have 2 million that are out there in use live on the internet at the same time. So I want to do a demo. It's always a little risky to do a live demo. One time when I did this demo in an earlier talk, something went wrong. But I guess that makes it more exciting. So you can actually follow along with this demo if you want. I'm going to get a cert for a site. And I'm going to show you that the site doesn't have a cert. And if you have a web browser open, you can look for yourself. And then we'll get a cert. And then if you have a web browser open, you can see that site load in HTTPS. So I was going to do, I set up example1.loyalty.org. Okay? So here's a site called example1.loyalty.org. I'm going to it insecurely in HTTP. And then I also have example2.loyalty.org, which is also insecurely over HTTP. Now, if I try to go to these in HTTPS with a secure connection, we're going to get an error. And it's showing another site on that server is having its cert served incorrectly, and it's not valid for this. So we don't have a valid cert configured on this. So we can get to it with HTTP, but not with HTTPS, which is the way that really quite a lot of websites have been for quite a long time. Okay, so I go back to the HTTP, and that can load there. Okay, so I'm here on the server. This is the server that's serving these things. We've written a client program. As I'll mention later, it's being renamed to CertBot. I don't have the awesome logo to show you, but we have a super cool logo of a robot shaped like a padlock holding a key. Okay. So,
sorry, is that going to kill all the cron jobs already running?
I think that the let's encrypt command will still work as an alias. We definitely have people worrying about that issue. So I'm going to run CertBot here on the server. Okay, and it analyzes my Apache configuration and notices that my Apache has these various things. And so I'm able to enable or disable individual ones. I can turn them on or off to be included for the cert. And these are the 4 things that are being served by this site. Okay, so example2.loyalty.org and example1.loyalty.org are 2 of the names in here. So I'm going to say OK. And it's trying to get a certificate right now. Hopefully it will get it. And it wants to know whether we should have HTTP and HTTPS both available, or whether we should redirect everything to HTTPS.
Redirect.
So I'm going to say redirect everything to HTTPS.
Why isn't secure easy?
Maybe easy is a misnomer there. So I chose the secure mode, and it says, congratulations, we've enabled it. It suggests that we take a look on the Qualys SSL Labs site to make sure that the configuration is good. I'm not going to do that right now. I'm just going to say OK. And then it says it worked. So I don't know if anyone's been following along in a web browser, but I'm going to go here and reload this. And it came up in HTTPS with the green padlock. And I'm going to reload this one, and that came up in HTTPS with the green padlock. So I just got a cert and turned on HTTPS for that site, and it was that quick. And if you look here, it says secure connection verified by Let's Encrypt. Same way over here, secure connection verified by Let's Encrypt. We can take a look at the certificate. This certificate was issued right now, 4/24/16. That's today. It was issued by Let's Encrypt Authority X3. Right? Oh, I'm sorry, that's the intermediate. This is us. Okay, so this was issued just now. It's backdated by 1 hour because some people's computer clocks are set wrong because of daylight savings time and stuff. So the certificate is backdated by 1 hour, but it was issued just now. And if we look at the subject alt names, it covers those 2 names that I requested, which is why the browser is accepting it. So I'm tempted to say that's all there is to it, and we're about done. But I want to describe a little bit more about the goals behind the project and the structure of the project and the software that we've developed. But the nice thing is that for many, many of our users, it's actually that quick and easy, and they get HTTPS, and that was our goal, and we've achieved it.
Where do you download this?
What's that?
Where do you download the CertBot?
So here's our let'sencrypt.org site. And if you click on Get Started, it talks about how you can get CertBot. Unfortunately, for some people, it's suggesting that you get the code from GitHub instead of getting it from your operating system package manager. We're trying to get in more operating systems so that you'll have a package in your operating system. Debian users have it already available in Debian with apt-get.
So you're working on Yum repository option.
Uh-huh.
Oh, cool.
I'm trying to get back to the... Oh, I see. Okay. Yep.
One other awful question. What if I have Windows servers?
There is a client that someone has written for Windows. Yep. It's not as mature and as polished as what I showed you, but there's a client that people have written for Windows. You can, yep.
I was just wondering, is there more to it than that? Will you issue a certificate for Microsoft.com?
So what you didn't see was that the client was proving that it controlled those names, which I'm going to talk about in a minute. It wasn't just that I said I would love a certificate for this name. There was actually, in that moment, where we were waiting for the certificate to be issued, there was a challenge that was going on where the certificate authority said, oh really? Well, if you really control that name, make this change. And then the client was automatically making that change to satisfy the certificate authority. So I would probably not have been able to make the same change on Microsoft.com.
Can you know this?
What's that?
Can you know how you try to Microsoft and failed?
I'm not sure if I'm supposed to actually try to achieve misissuance as a person working for the CA.
Yeah, probably not good. If you take off your lanyard,
I mean, I can say certbot-d, this is impossible.example.com.
There we go.
Okay. So there's a problem here that the client says it doesn't look like you're serving that on your server. So the client says, I don't know how to do that.
So as long as your source IP matches DNS resolution?
Your source IP doesn't have to match, as long as you can make a change to the site. You don't have to be running this on the same machine where you're...
Demonstrate control.
You have to demonstrate control. Yeah, so if I'm now trying to get this is impossible.example.com using, right, the following errors were reported by the server, and well,
There's no DNS.
there's no DNS for that name. But we would, if I did it for a real domain, I would get a different error that says DVSNI challenge failed to this
Just
name.
use example.com.
Okay,
That actually does resolve.
that does resolve, right?
Still.
Right, but it should fail with a different error, I would think.
Right. Yeah, correct name not found for TLS-SNI challenge. So that was a challenge that was issued, and I wasn't able to make the change. And it looked on example.com, and the change wasn't made to example.com. And so the certificate wasn't granted to me. Yeah, that's a pretty fundamental thing about having a certificate authority. You're supposed to check if people own the name. There have been a couple of scandals where some certificate authorities didn't seem to understand that. But, all right. So I'm going to use a couple of slides that I used last year, so I'm sorry to anyone who was in the room last year if you've already been through this. But, you know, until pretty recently, we had found a number of people saying, oh, I only need HTTPS if I'm taking credit cards, or I only need HTTPS if I'm dealing with financial data. And, you know, at EFF, we're privacy advocates, and we thought that was a very narrow vision. And we thought that trying to protect someone's credit card was really less significant than trying to protect, for example, their emails or instant messages or what encyclopedia articles they were reading on Wikipedia. Things that can be very sensitive and very personal, but that aren't financial records and that aren't credit card numbers. I think there has been a real shift in the last couple of years in understanding, and a lot of people have come to understand that security technology is really important. Some people still say, well, only if you're logging in do you need it. And I think there are other examples. You know, there's the sensitivity in what you're reading. If you're reading on Wikipedia, you have an important privacy interest in which articles you read. HTTPS may not actually be able to protect that because the articles are different sizes, and that's a problem. And encrypting something doesn't change how big it is. But I think the Wikimedia Foundation may be able to work around that, and encryption is a necessary step, if not sufficient. And I had an interview with a journalist, and we were talking about Wi-Fi spoofing. And I did a demonstration for her spoofing a Wi-Fi network. And then we did an example with searching for something on webmd.com, and you're searching for symptoms of diseases. And then they all just show up in the packet sniffer. They didn't have HTTPS. And I think they might have said, oh, this is all public information. We don't have logins. So we don't need to protect your login. But they need to protect the symptoms of the disease that you're searching for and which medical conditions you're reading about. So I'm hoping that all of the internet world will become more aware of the various security issues. You know, another one is software downloads. There are a lot of software projects that offer a download of their software, and they may not have HTTPS. And that means that whoever controls the network is able to substitute other software when you download it. And I have a whole talk about that as well. Okay. Right, so reader privacy, integrity of software downloads, content-based censorship. There are even internet service providers that have been injecting ads as an ISP, injecting ads into your connection by modifying the HTML source of pages that you read, and they put in their own ad, tampering with the page.
I got that on gray now.
Yeah?
Yeah, the bolt bust up. I turned on HTTPS everywhere I've done.
Wow, so some people have personal recent experience with this. Yeah, so then we've asked people, why didn't you turn on HTTPS on your site? And some of them said, well, it's kind of slow, or it requires a lot of server resources. Increasingly, that's not true, especially thanks to hardware acceleration of crypto in a lot of people's processors. So you don't necessarily have to run all of that code on the processor to do the crypto operations. You may have an instruction in the CPU that can do encryption or decryption in one operation, which is nice. It's made the computational overhead of TLS a lot lower. And then some people said, we have a complicated data center, we have a load balancer that's not very compatible with this, we need any instance to be able to handle any session, but if we have an encrypted session, that will no longer work. So that's a challenge for some people. But the thing that we heard over and over again, especially from smaller sites, is the difficulty of getting a certificate and the difficulty of installing it, and sometimes the cost of paying for it. And so we set out to eliminate all of those barriers. We talked to people who had gotten a certificate, who weren't very accustomed to doing it, who were system administrators who understood the process, but who just didn't have regular practice doing it. And it often would take them an hour to research how to generate the certificate signing request, and how to generate the private key, and then how to upload it to the certificate authority, and then how to complete the verification of domain control, and then how do you install it in your web server, and all of this together would take people about an hour to figure out all of this stuff. And they would have to look on some random website to find the OpenSSL commands to run to generate all of these PEM files. Okay, so a lot of people said that's really annoying. So we said, let's eliminate all of these barriers and just make it free of charge and immediate and automated. And so we got together with the University of Michigan and Mozilla. We discovered that Mozilla and the University of Michigan had the same idea at the same time. So it really shows that this was sort of an idea whose time had come. And we got a number of commercial partners. We have a number of other sponsors now. And we were able to actually make this happen. There was a question about whether browsers would accept our certificates. As you can see from the demo there, and if any of you went to that site to check for yourselves, browsers do accept them. The way that we were able to achieve that is by getting a delegation of trust from an existing CA called IdenTrust. And so IdenTrust has signed an intermediate certificate for us saying that we are a CA, and we can send that along with the certificates that we issue, and then browsers will accept that transitively. Yep.
So, 2 questions. Are you cannibalizing some of their business by doing that? And number 2, did they do it because you're such a great guy, or what's the business relationship here?
So we do have a business relationship with them, and the people who run ISRG have asked that I not talk about the details of that. So I'm sorry about that.
Suffice to say, it works.
It does work. I think everyone involved is happy with the situation. Yeah?
Does it cost you guys?
I don't think I'm supposed to describe the nature of that. I mean, I can look into more what I can say, but I don't know what I'm supposed to say or not. Yep.
Are you working on becoming a root cert so you're not...
We are working on becoming a root CA in our own right. So we've applied to the main browser root CA programs, which is how one becomes a root CA. We do have our own root. We don't use our own root day to day because no browsers currently accept it. But if the browsers did accept that, we could use that as an alternative to the IdenTrust signature. And we hope to be able to do that in the future. Yep.
Expanding on that a little bit, if you do get your own root, what is the process of getting the root into like all browsers?
We have to apply to the browser's root programs, and the browsers have to decide to include it. So each browser, at least nominally and seemingly often in practice, has its own review process, where they have their own documents that they want to see and their own demonstrations that they want to see of our capacity and that we've passed audits and so on. We had to pass a WebTrust audit in order to get the IdenTrust signature, because IdenTrust isn't just going to give out the signature to random people who haven't been audited as a CA. And so I think that the audit that we got to get the IdenTrust signature is also the same kind of audit that the browsers would want to see in order to potentially include us as a root. Yep.
Where is this software blocked? Is it blocked like in the Republic of China or in some other countries that have different views about this stuff?
So I have not heard any specific reports about our tools not working in a particular country. I did have someone come on the support forum who was hosting a website in China who said that in China there was a law that in order to have a website, you need to obtain and display on the website a registration from a certain government agency. And that they have spiders that go and check websites in China and check whether this registration is displayed on the site and whether it matches their records. And then they take action against the ISP for permitting someone to host a website if they don't have that registration. So we had someone on the support forum say, AWS in China is not willing to let me listen on port 80 because I don't have my government registration. So can you perform the proof of control in another way? And we described the other way that we can perform the proof of control, but it didn't work well for this person. But that was not specifically that the government of China was preventing us from doing the validation or preventing us from issuing the certificate. Another one that I've heard about, but I've been unable to get an update recently, was Kazakhstan, where there was a report that suggested that for outbound connections to websites, they would all be man-in-the-middled with an intercepting proxy like some corporations use. And all users would have to accept the government CA which would then man in the middle all TLS connections that originated from within Kazakhstan. I don't know if that plan has gone ahead. So neither of these things would stop people from using our certs, but they might affect who is able as a practical matter to get or use them or how. I have not heard of the government specifically saying that using our service is illegal or that it will be blocked for technical reasons. It's possible that that could happen in the future. I can also mention that we have been more able than some other US-based CAs to issue certs to end users in Iran. The US government has very extensive sanctions against Iran, but the sanctions have exceptions for communications-related services. That is, things that facilitate the ability to communicate, as opposed to, for example, selling physical goods. And we were able to have lawyers look at the sanctions policies and determine that we're allowed to issue certificates under the Office of Foreign Assets Control policy to non-governmental entities in Iran. And so we've made that clear that we're allowed to do that, and we do that. Differently from a lot of other CAs in the US. Yeah.
How could you block a government agency in Iran from requesting a certification from you?
I think we know top-level domains that are used by the government agencies.
Okay.
And we wouldn't be able to issue for those because those are more stringently sanctioned, as I understand
So
it.
you maintain a blacklist of domains?
We do have a blacklist of domains. We have a blacklist of domains related to some concerns about misissuance. And we have, I think, a small blacklist of domains for other policy reasons. We're trying to always keep the blacklists very small and have other security controls in favor of a blacklist where possible. Yeah.
You don't issue wildcards?
We don't issue wildcards.
Are there plans to?
We don't have any plans to issue wildcards.
But if they're free, you can just keep on issuing as many as you want.
There are some use cases that need a wildcard. There are a lot of use cases where being able to get a free certificate in a minute would mean that you don't need the wildcard because you can just go and get a certificate that adds a name whenever you want to. We do have a rate limit. The rate limit has been increased a bit. But for example, for a small business or small educational institution, we could probably substitute for the wildcard pretty well by allowing people to just frequently update the cert. There are use cases that people have described that I think are very real and very legitimate that would require a wildcard, and we're not able to satisfy those. Basically, where people don't know in advance what all of the host names are that someone might come to. For example, there's a project called Sandstorm, which is a really great project that uses the host name as part of the application data for various purposes. And Sandstorm wanted to do HTTPS, and people don't know ahead of time what the names are that are going to be covered. And they sort of can't know ahead of time because they're dynamically generated, and there can also be hundreds of them, depending on how you're using the service. And so we're not able to support that. Just to continue a bit, there is a kind of validation that's done by certificate authorities that's just checking that you control the domain name. This kind of validation can be automated. So I had a joke that we could then replace the certificate authority with a very small shell script. In practice, it turned out to be a bit more complicated because there is a lot of engineering work to be done. So it's actually some Go code that we wrote that is open source that's available on our GitHub page. It's called Boulder. We're trying to make a lot of jokes about the Roadrunner cartoons. So our protocol is called Acme, which I'll talk about in a minute. And originally, our certificate authority software was called Anvil. But we were embarrassed to discover that there was already a certificate authority software called Anvil. So we renamed it to Boulder. And we have fully automated certificate issuance. So we're issuing many thousands of certificates per day, and we don't have a human being in the loop for those. And that's what makes it possible to be free of charge, because we don't have to pay a human being to review these applications manually. We can really scale up without having to charge people at the individual certificate level, as many certificate authorities traditionally have done to support their operations. Yeah.
Is any other CA talking about using Acme?
I'm not aware of another CA that's using Acme. We certainly wish that they would. We think that would be great if these clients could be reused by other CAs. They're obviously very welcome to. Yep.
For the whole Iran thing, how do you get away from ISO or DAR restrictions?
We had lawyers review all of the legal issues, and they were satisfied that we were okay.
Okay, so even like crypto export issue, or I guess you're not distributing SSL.
We're not distributing OpenSSL ourselves. So our code is on GitHub, and any crypto-related project that's on GitHub allows anyone to download it whom GitHub allows to download it. And if they're using a real open source license, then they're not specifically actively restricting who can download it. Now, it's true that the government has considered this to be an export that may be regulated by export controls in the past. There are some exceptions to that. EFF, where I work, sued the government to argue that these restrictions were unconstitutional. So there's a long story there. But I can tell you that the lawyers are currently satisfied. And if you want to know more about the export control aspects, I can put you in touch with lawyers who've looked at this, because it is a significant issue that projects may have to deal with. So the basic concept, which you just saw demonstrated, is that the client program, such as CertBot, which is running typically on the user's web server, connects to the Let's Encrypt certificate authority. And that might come with your operating system or might be built into your web server, or if you're using some kind of hosting platform or hosting service, they might offer it for you. And we have this protocol called Acme, which I mentioned, Roadrunner themed name. We figured out that it could stand for Automated Certificate Management Environment, but we really just wanted it to be a Roadrunner type name. And that lets the client and the server talk to each other about the certificate issuance process. Right, and when the client is asking for certificates, the certificates cover particular names. It's definitely an industry requirement and a security requirement that the certificate authority should check whether the entity asking for the certificates really controls the names that will be in the certificate. So we have to have a way to do that. And we've worked out a set of challenges where the server challenges the client to do something to prove control over the domain. And we have 3 kinds of challenges currently, which involve making various kinds of configuration changes on a website or in the domain records. And if the client is able to make the specified changes, and the certificate authority is able to see that those changes have happened exactly as requested by the CA, then the CA is willing to issue the certificate and make it available for download. Yep.
What if someone, shall we say, takes over one of these machines and then runs your client? I mean, is there a way to tell that?
Sort of certificate revocation is this one.
So, if someone compromises a machine, they can use that machine and cause it to request certificates and cause those to be issued. That's actually something that was the case before Let's Encrypt, because domain validation existed before us, and the ability to make changes on a site was accepted by other certificate authorities for domain validation, for proof of control. So it's been the case for some time that if you compromised a machine, you may be able to cause it to request certificate issuance. I think we're doing better than some other CAs, as I'll get to in a minute, because we're participating in the certificate transparency system. So we publish a list of everything that we issue. So if you're concerned that something may happen to you, or you're just interested in what certificates are out there, you can automatically look and see what certificates we've issued. And so if someone else does something sketchy to you and causes issuance of a certificate for your domain name, you can find out about that. Even if they're not actively using it in the wild, we will proactively disclose the fact that we issued it. So that's one thing that you can do. Okay. So we have, our organization's created an independent nonprofit to operate the certificate authority. It's called Internet Security Research Group. That was a name that was meant to be as generic as possible so that no one would realize what we were going to do. And it worked. People didn't guess that ISRG was going to operate as CA. Now, obviously, we've announced that that's what we do. We've got the audit. We built out infrastructure and data centers and started issuing certificates. And we're already one of the largest public CAs by the number of certificates issued. It's a little bit difficult to get good statistics about this. I've heard a claim that we're in the top 4, and I've heard a claim that we're in the top 3, and I'm not sure where to get the best numbers to figure out exactly where we are in that ranking. But it seems pretty clear that we should be in the top 5 largest CAs by number of certs issued. So that was pretty quick, since we've only been publicly issuing certificates since December. We do have our client packaged in Debian. You can get it in Debian systems and Debian-based systems with apt-get. Our client was called Let's Encrypt, and we're in the process of renaming it to CertBot in order to make clear that it's not the same thing as the certificate authority itself. A nice advantage of it is that it can parse and modify Apache configurations. So it can detect what sites you're serving in Apache, and then it can actually install the certs into your Apache. Some people find that a little scary because they don't like scripts modifying their configuration files. So you definitely don't have to use that feature, but people have found it pretty convenient. And we're working on EngineX Integration, and we would like to have integration with other web servers as well. There are about 20 clients out there. So our CertBot client is not the only client that can be used with the certificate authority. Other people have written others. Some of the other ones are more lightweight. Some of the other ones don't attempt to modify your web server configuration. A reason that you might want the ability to modify the web server configuration is for automated renewal, because the certificate will expire and you'll need to get a new one. So we're very focused on the idea that you could have a cron job that will automatically run and automatically renew your certificate and automatically install the new one. And that's a pretty important feature. Obviously, for some of the other clients, there are also ways to set up automated renewal. It's not as though other clients don't have that possibility. And they all offer different things, and they have different kinds of integration, and they're written in different languages. There is one written primarily using PowerShell that's meant for Windows Server systems. So that's something that exists. As I said, it's not as polished as CertBot. But we're aspiring as a CA to support clients for every platform and every kind of server environment. Yep.
Have you guys considered adding, or has anybody added in their version a feature to allow the other way, client authentication from the browser using Let's Encrypt certificates? So you have two-way.
Our CA is totally focused on server authentication. We're not sure how we can automate other kinds of things. There are other things that digital certificates are used for, and people often ask us about those, but we're not sure that we know how to automate them. Whereas we were sure that we knew how to automate this one, so that's what we did. Yep.
You care about automation a lot, but if I recall, the Acme protocol has some like I agree to the TOS field, which kind of involves a human being in the loop. So I'm responsible for an HTTP server, and we want to kind of make all this automatic. To what degree do we force the user to check some box or put something in their config file? I noticed in your demo you never agreed to anything.
The reason that I didn't have to agree to anything there was that I had already used that client to connect to the server, and it had already done that.
Registration, do you have to agree?
Yeah, so the first time that you run the client on a particular machine, it creates an account on the server, and then there's an agree thing. And the need to agree to terms of service was a requirement from the CA industry. So it wasn't, to my knowledge, it wasn't that we thought, EULAs are really great and we want to make people have to click I agree on things because we love doing that. It was that the certificate authority industry said there needs to be a contractual relationship between the CA and the subscriber that says that the subscriber agrees to use the certificate appropriately.
What is an example of an inappropriate use?
Well, I can show you our policy. It's primarily that you'll use it on a server where you actually control the name. You won't use it to pretend to be a site that you're not.
But if you're a bad actor, you're going to agree to that anyway and still try to do it.
Well,
that's not something that you can solve with a click-through.
The CA industry is very built on bureaucracy. So the CA industry...
Is the whole point of Let's Encrypt to disrupt that industry, though? In some respect.
But we wouldn't have been able to get the ISRG signature without having this.
Fair enough.
So can I infer that you're not actively enforcing clients forcing users to click this box?
We have a post about this question that was on the community forum. So maybe the best thing is to look for that thread. So we have the Let's Encrypt community forum, which is here. And there are lots of discussions about various things, including client development. And people have asked about sort of what does the CA think is necessary in terms of clients checking that a user agrees. And so that is a question that's come up here. So maybe I could find that thread for you and point you to it. I'm sorry about the EULA. I mean, I hope I'm one of the people in this room who likes EULAs the least. It's really something that came from industry requirements that we didn't write and that we were subject to in order to get this power. And we have, yeah. Here's the subscriber agreement. Okay.
Just real quick, when you said that it's required by the CA industry, what does that mean? Is that the auditors that you used to review your thing, they required it, or the, oh, okay, the CA form? Okay, so this is also browser vendors.
Yep.
Okay, got it.
So these are the folks who currently draft the rules for how you can become a CA that's trusted by browsers. And all of the CAs then have to follow these. They have the CA browser forum baseline requirements, which are a long set of requirements. Yep.
I mean, presumably the rules were written prior to the concept of an automated CA, so is there a chance that you could change the rules?
We're now a member of the CA browser forum. We've been a member for about a month.
Have one vote.
So we do have one vote. Yeah. We can certainly have discussions in the forum. There are a lot of other folks there, some of whom are our commercial competitors, who might not agree to proposals to radically change these concepts, but we could definitely bring up these questions there. I mean, I think that people working on Let's Encrypt would like to see all aspects of this become more automated than it is. I think that's a goal that we all have. Yep.
Yeah, do you publish a list of hosts that actually support Let's Encrypt? Because I know there's a bunch of hosts that aren't participating right now.
Yeah, on the community forum, there's a thread about that.
I think that's one way to get them to adopt it, is you can push them to do it.
There's a thread on the community forum about that, so that's the best that we have for right now. All right, let me just come back here for a moment. Right. So I just wanted to mention we're supporting Google's Certificate Transparency Initiative, which means that we publicly publish somewhere outside of our own control a list of all of the certificates that we ever issue. And we have promised that we will always publicly publish certificates when we issue them. So if you're concerned about the possibility that we may misissue something, that someone may try to trick us, that someone may try to force us, you can look in the certificate authority, the certificate transparency database and see what we say we've issued. And if you ever find something that we've issued that someone is using that doesn't appear in that database, that's very bad, and you should definitely tell everyone about that and demand that we explain why. And eventually browsers may even require proofs of inclusion, which is a cool feature about Google's design for this. Eventually a browser may require a proof that the certificate that it's being asked to accept has been publicly disclosed. Because if an attacker could get a certificate misissued and then secretly present it only to certain users, those users might be attacked, but the site owner might never know that this happened. Whereas with certificate transparency plus mandatory proofs of inclusion, either the browser would reject it because it didn't know it was available to the public, or it would be available to the public and everyone could see what happened. So I think that would make the certificate system a lot better and a lot less reliant on just trusting in institutions. Thanks. Also, if you don't want us, this may not really apply to people who chose to come to this talk at LinuxFest Northwest, but if you don't want us to ever issue certs for you, which does apply certainly to some companies and some sites, you can use a protocol called CAA, Certificate Authority Authorization, and say, Let's Encrypt should not issue for me. And then we will not issue certificates for your site, as long as we can see that in the DNS. So we would like to be supported everywhere to make this really easy and really convenient for people. A really nice example is that WordPresscom, as of earlier this month, uses us to provide certificates for all of their users, all across WordPresscom. And that was great. That was one of the events that caused the tilt of the line to go up a bit.
I think AWS is now issuing certificates. Are they using you? They have their own.
They have their own. And it's great if people find other ways to do it. We definitely don't need everyone to use us if they have alternatives. Yeah.
Does something somewhere explain the challenge mechanisms, the way the challenge actually occurs?
Yeah. The Acme protocol specification is probably the best reference for that. You can also look at the source code for our client or our server to see implementations of the challenges. But the Acme protocol specification is probably the best place to see how the challenges work, what the changes are that you have to make, and how they're communicated through Acme. Yeah.
Speaking of Acme, is there a timeline for Acme HTTP01 verification support ports other than 80?
We're not planning to support ports other than 80. And the reason is that we want to make sure that the people who are requesting the certificates are root on the machines. It supports...
But those aren't the same statements.
Right. So there are a lot of shared hosting environments in which people can listen on various ports who aren't the system administrator and who are sharing that machine with other people who are unrelated to them. There is a traditional distinction in Unix between ports below 1024 and ports above 1024. So there's a theoretical possibility that we could have some other ports below 1024.
Is there a timeline for supporting ports under 1024?
So we're still not sure what the best policy from a security point of view for that is. So there's not a timeline for that. This is definitely, you can talk about it on the community forum. There's a long thread about it. We've gotten this question quite a bit. And we're quite concerned about multi-user systems and the possibility of people who happen to share the same physical server and IP address but are completely administratively unrelated being able to complete challenges for one another. Yep.
So if, say, a company controls the site, normally would use 80, but their security policy says we have to use proxies like 8080, would it?
So we will never validate to 8080. Because if you have a multi-user site, a multi-user server, anyone on that server can run software to listen on port 8080. And so if you had 300 different customers of a hosting provider, all hosted on the same server, one of them can start listening on 8080. And the DNS names for all of the others are pointed at that same host. So we definitely would not feel safe doing that validation. So we can currently validate using certain kinds of control on port 80, certain kinds of control on port 443, and certain kinds of changes to the DNS records. And those are the validations that we support so far. If people want to propose other kinds of validations or other changes to those, you can join the IETF Acme working group and talk about other possible challenge mechanisms. We definitely don't mean to suggest that these are the only challenges that we could ever do. But we think that other challenge mechanisms need to be very well discussed and very well studied. So they can be brought up in the IETF Acme working group. They can also be brought up on our community forum. Yep.
Do your challenges originate from a known IP block?
Currently our challenges do originate from a known IP block, but whenever people ask us where it is, we say, we're reserving the right to change it or to make them come from random or unpredictable IP addresses. So we don't want people to put firewall rules or the equivalent of firewall rules that only listen to a particular inbound IP block, because in order to reduce the effect of BGP spoofing attacks, We want to, in the future, have the ability to check from unpredictable network paths where people won't know what to expect, so they won't necessarily know what to attack, or at least several places on the internet that we may change from time to time. And so we don't want firewall rules that say, oh yeah, let's encrypt check from over here, but not from over there. I think we're being told that we're out of time. So